Let's say we have a particle whose proper lifetime is 2 times 10 to the minus 6 seconds. And in the laboratory, we speed the particle up to close to the speed of light, or some value that we want to determine, and we find that it travels a distance x, say 500 meters, during that lifetime. And then it disintegrates. So the distance traveled is the speed at which it travels, right? So we want to know the speed at which it's traveling and the time in the laboratory t, but that's not the proper time. So, right, the proper time is tau, right? And so t is tau over 1 minus v squared, square root. But if we want to find v, we should be careful that if we want to find v in meters per second, then we need to include the factor of c squared there. So x equals v times tau over 1 minus v squared over c squared square root is our relationship, and we're going to solve this for the speed v. So we have x over tau. Let's square that, and that will be v squared over 1 minus v squared over c squared, at which point we will, right, if we multiply both sides by this 1 minus v squared over c squared, then we'll get an x squared over tau squared minus x squared over tau squared v squared over c squared. So that brings an x squared over tau squared c squared, v squared, when we bring it to this side, times v squared plus a v squared that's already there. So we have this plus 1 times v squared. And so v is x squared over tau squared divided by x squared over tau squared c squared plus 1 square root. So let's plug these values in, and let's see what speed we get. So x squared is 500 is 5 times 10 to the 2, so we have 25 times 10 to the 4 over tau squared, which is 4 times 10 to the minus 12, right? 4 times 10 to the minus 12, and we're dividing that by 25 times 10 to the 4 divided by tau squared, which is 4 times 10 to the minus 12, times c squared, which is 9 times 10 to the 16, right, in meters per second squared, meter squared per second squared, plus 1 square root. This is, so we have the square root of, let's see, 25 divided by 4, 6, 12, 18, 24. So really it's a little over 6, but let's just leave it at 6. 12 and 4 is 16, so 10 to the 16. We're dividing by 6 times 10 to the 16, 9 times 10 to the 16 over the common factor, which is 9 times 10 to the 16 here. What do we get here? 6 times 10 to the 16 over 15 over 9 square root. So that's about 10 to the 8 for this term, right? And 6 times 9 over 15 square root, that is the square root of 18 over 5. So that's actually exact. 18 over 5 square root, that's a little bit greater than, so it's a little greater than 3, so square root of 3 is 1.7, so it's a little less than, I don't know, it's about 1.6, let's say, times 10 to the 8 meters per second. So it's more than half the speed of light if we did that correctly.